Let us solve another problem on finding the collapse load in case of a fixed beam. So in this problem, this is a fixed beam AB which has got two values of MP from A to D, that is for half this span it is 2 times MP, and from D to B it is MP. So that means there is a change in the geometrical property. So the cross-sectional area, moment of inertia, it is changed from A to D and D to B. That is why the value of MP is also different. So in such a case, as I already told in the earlier videos, plastic hinges will be formed at the supports, that is at A. So totally you will be having 4 plastic hinges. In this case, plastic hinges will be formed at the supports, that is A and B. Then under the concentrated load, that is at C, and also at the section where there is a change in cross-sectional area or a change in the value of MP, that is at D. So totally you have four plastic hinges, but since it is a fixed beam, the redundancy is 2 here, and the number of plastic hinges required to form the collapse mechanism is R plus 1. That is minimum. You could have 3 plastic hinges to have the beam mechanism. So therefore, even though 4 plastic hinges will form in general, but since to attack the mechanism you require only 3 plastic hinges, so here also we have to take 2 cases. In the first case, let us take that the plastic hinges will be formed at A, B and C. In the second case, we take the plastic hinges to be formed at A, B and D. So only 3 plastic hinges are enough. So we have to calculate the value of collapse load WU. So W is the load given here. So when the structure attains the collapse mechanism, the corresponding load will be WU. So we have to calculate WU value for both the cases. So taking A, B, C plastic hinges at A, B, C, and in the second case taking plastic hinges at A, B and D, and we will get 2 values of WC. So among the 2 values, the minimum value will be the final answer for WC. Now let us take the plastic hinges to be formed at A, B and C. Let the plastic hinges formed at A, B and C in the first case. Now the corresponding mechanism will be something like this. So here this is A, this is C. So you can see that C is at the distance of L by 3 from A. So naturally this will be 2L by 3. So total is L. So it will be 2L by 3. And the corresponding mechanism will be, so 3 plastic hinges will be there, one at A, another at B, and one more under this C. So you will be having the mechanism like this. So you can see here, this is the load is acting here, W. So under the load, whatever deflection is there, that time we take it as delta. Now since this W is not acting at the center, these values of rotation should be different. This is theta, this is theta, this will be theta 1, this also will be theta 1. The total rotation at the C will be theta plus theta 1. So this is the beam mechanism for the first case. So taking the plastic hinges at A, B and C. Now let us write the values of MP here, fully plastic moment capacity. At A, from A to D, he has given the value of MP as 2 MP, therefore at A it is 2 MP, at C is also it is 2 MP, at C is also it is 2 MP, and at B it is MP. So these are the values of MP at the corresponding points where the plastic hinges are formed. Now we have to write that principle of virtual work. So according to principle of virtual work, internal work done will be equal to external work done. So internal work done will be due to the formation of hinges, plastic hinges. External work done is due to the external loads. So loads acting on the beam. Now here internal work done is given by product of the MP value and corresponding rotation at that point. Now I will take one by one. At A, the MP value is 2 MP and the corresponding rotation is theta here. Then plus at C also it is 2 MP, whereas the rotation is theta plus theta 1, plus at B it is MP and the rotation is theta 1. So this is the internal work done. This should be equal to the external work done is the product of the collapse load multiplied by the corresponding deflection under that load. So WU into delta. So now from this diagram, you can get the value of this tan theta. I can write here. So earlier problems also I have explained. Tan theta can be equated to theta because theta is very small in radians. Tan theta in this triangle is delta by L by 3. So therefore I can write delta as L by 3 into theta. So this is one relation. Now if you take the other triangle, tan theta 1. So theta 1 can be equated to tan theta 1. So tan theta 1 will be delta divided by 2n by 3. Or I can write delta as 2n by 3 into theta 1. Now you can see that both are equal to delta. Therefore I can write L by 3 theta is equal to 2n by 3 theta 1. So L by 3 and this L by 3 will get cancelled. You can take theta is equal to theta into theta 1. So this is relation between theta and theta 1. Now in this principle, so what we can write here is substitute for delta as L by 3 theta and substitute for theta 1 as theta by 2. You can write theta 1 as theta by 2. So that two unknowns will be reduced to one unknown. So what I can write here is it is 2 MP theta plus 2 MP theta into theta plus theta by 2. For theta 1 I can put theta by 2 plus MP into theta by 2 is equal to WU into delta is L by 3 theta. Now you can cancel the common term that is theta here. So if you simplify this, MP theta I can take outside. So if I take MP theta outside, so in the LHS it becomes 2 plus 2. Here it is 1 plus half. 1.1 to 2 is 3. So it is 2 plus 3 plus 0.5 half. This will be equal to WU into 2 by 3 theta. Therefore, we can cancel this theta. So you can find out WU in terms of MP. So it is like this. So you can write this MP into this is 5.5 will be equal to W into 2 by 3, or I can write WU is equal to 3 into 5.5 that is 16.5 MP divided by 2. So this is what you will get. So WU is equal to 16.5 MP by 2, or I can write it as 8 point, so 8 point something. So here, so WU is equal to 16.5 by MP or L by L is there. So I have not written that WL by 3 theta. This is WL by 3 theta. WL. So you are getting divided by L. So this is the value for the first case, collapse load for the first case. That means assuming the plastic hinges will form at A, B and C, so that this is the value of collapse load we are going to get. Next, in the second case, let the plastic hinges, because only 3 plastic hinges are enough. So totally 4 will form, but when 3 plastic hinges are formed, then the mechanism will occur. Let the plastic hinges form at A, B and D. A, B and D. So in this case, the mechanism now will be like this. So there is a plastic hinge at A and B, and D will be here. D is the midpoint. Actually, it is a midspan point. So D will be here. So the mechanism will be like this. D mechanism will be like this. So, but here, please note that W is acting here. So we have to take the direction here, not here. So here also, of course, here in this case, what happens? D is the midspan point. Since it is a midspan point, so these two angles are this way. So this is theta, this is theta, this is theta, this is also theta. Therefore, total rotation at D will be 2 theta. Theta plus theta, 2 theta. Because D is the midspan point, so this is the mechanism, beam mechanism for the second case. Now, when you write the values of MP values in these cases, so what happens is at A, the value of MP is 2 MP, at B it is MP, but see here at D, the 2 MP value will change to MP value, so we have to take the minimum of that is MP value. We don't take 2 MP, at C it is 2 MP, but at D it changes from 2 MP to MP, so we have to take the lesser value that is MP here. So for this diagram, we have to once again write the principle of virtual work equation. Internal work done is equal to external work done. So internal work done will be due to the formation of hinge and the corresponding rotation. External work done is the load and the corresponding deflection. So here, so internal work done will be now, I have to take at A it is 2 MP into theta, plus at D it is MP into 2 theta, plus at B it is MP into theta. So this is total internal work done. This should be equal to WU into delta. Now we have to substitute for delta now. So how to get the value of delta? We will see here. So this value, you can take it as delta 1. If that is delta 1, what about delta we will see? So here, this from here to here it is N by 3, that is given in the problem, and from here to here it is N by 2, whereas from here to here it is N by 2 minus N by 3, that is N by 6. So N by 6 it will be from C to D. C to D it is N by 6. These are the distances now. Now I want to get the value of delta. So delta is equal to, according to this triangle, by this triangle, tan theta can be equated to theta, because theta is very small. It is delta divided by N by 3. Delta by N by 3. So therefore, delta is equal to N by 3 into theta. This is what you will get. N by 3 into theta. Now I can write there for delta as N by 3 into theta. Now this will be simplified. 2 plus 2, 4 plus 1, 5. 5 MP theta is equal to WU into N by 3 theta. It is N by 3 theta. Now you can write down the expression for this theta will get cancelled. So therefore WU is equal to 3 into 5, 15. 15 MP by N. So this is the value of collapse load for the second case. That means second case means when the hinges are assumed to form at AB and D. So we have got two values of WU now for the first case and second case. Among these two, whichever is least, that is the value of final collapse load. So among these two, the minimum value is 15 MP by L. Therefore, we can write collapse load for the given fixed beam is the minimum value of WU, whatever we have obtained, that is equal to 15 MP by L. So this is the final answer. So even though 4 plastic hinges form in this case, so to have the mechanism, only 3 plastic hinges are enough, R plus 1. So we have to take 3 plastic hinges. So usually what we do is at the fixed ends, because of the development of the hogging bending moment, you can have 2 plastic hinges at the fixed end and one more under the load. You can take that as the first case, and in the second case you can take the third plastic hinges to form where the cross sectional area changes. So calculate apply the principle of virtual work and get the value of WU by equating internal work done to external work done. Internal work done is nothing but the product of MP value and the corresponding theta at that point, and external work done is nothing but the product of the load and the collapse load and the deflection under that load. So by equating those two things, you can get the value of WU, and since there are 2 cases, so 2 values of WU you are going to get. Among them, whichever is minimum, that is the final value of collapse load.